Hey everyone, welcome to the channel. In this video, we are going to discuss a problem called linked list cycle that is numbered 141 on Leetcode. The question goes as, given the head of a linked list, determine if the linked list has a cycle in it. There is a cycle in a linked list if there is some node in the list that can be reached again by continuously following the next pointer. Internally, pos is used to denote the index of the node that tail's next pointer is connected to. Okay. Note that pos is not passed a parameter. Return true if there is a cycle, otherwise return false. So if we look at the examples, the first example goes like 3, 2, 0, minus 4 and minus 4 points back to 2. So we can see that there's a cycle here. We need to return true. In the second example, 1 points to 2 and 2 points back to 1. So we do have a cycle. We need to return true in this case. In the third example, we just have 1 which points to a null. We definitely return false here. So to discuss the problem, let's go over to notes. Uh, when we say that a list has a cycle, we know that a node can be reached from two places, right? Uh, there could be multiple nodes over here. When this node can be reached from two places, we know that there is a cycle. When I said it can be reached from two places, this could also be a head. I mean, I'm starting from here and I can come back here. In that case also, the list has a cycle in it. So when I say the list has a cycle, what I basically want to find is if there is any single node which can be reached twice, right? So the first basic idea is we can visit all the nodes, right? And then traverse all the next. While doing so, if we find that any of the next from the following pointers points back to the current node, there is a cycle. If not, we can go to the next node and check for the next pointers of all the following nodes. So what I mean here is, let's say we have a list of this sort. I can start from here, D, this is E, F, and G. I can start from A, and then I can check the next pointer for B, C, D, E, F, G. I can go to B and I can check the next pointer for all of those. I can go to C and I can check the next pointer for all. And when I come at G, I see that the next pointer is pointing to myself. I know that there is a cycle. So this is a working solution, but there are two problems to it. One being I'm doing a huge amount of computation since I'm going to each node and checking the next pointer for all the following. And I'm doing the same thing when I go to B. I'm doing the same thing when I go to C. And the next thing is, if I don't know the length of the list, I don't know where to stop my computation, I could end up in an infinite loop. So what I mean here is, when I'm checking for A, I go to B and I see B's next, I go to C, I go to D, I go to E, I go to F, I go to G, and I see that G's next is not A, and I keep going on, and I could probably end up in an infinite loop inside the cycle, right? But if I know the length of the list, I could probably end up here, but the question does not give me the length of the list. So this solution will uh, give us a huge problem. We would end up in a infinite loop. And in the previous problem, we saw that all we did care about was whether I was finding a node which points back to myself, right? I just need to know whether the next of any particular node has been seen before. So what this gives me an idea of is basically a hash map or a hash set. So what I can do is when I'm traversing the list, I can maintain a set of all the nodes that I have already seen. So in my set, what I would do is when I'm at A, I would store a A here, then I would store a B, then I would go to C and I would store a C, and I would go to D, I would store a D, then I go to E, I store a E, then I go to F, I store a F, then I go to G and I store a G. In this point, when I come to C, I know that I have already seen a C. This totally tells me that from G, I'm coming back to a node which has already been seen before. And when I know that I have seen a node before, that basically means I'm seeing that node twice. I'm reaching that node from two places, right? So this, when I end up here, I know that I have seen a cycle and I can return true, right? So this can be a working solution to it. So if I have to go on with this, I know that the time complexity for this is order of n, while the space complexity is also order of n, as I'm using a hash map, right? This can give you a good solution and this can actually give you the answer. Now, if I want to improve on it, if I don't really want to use this order of n space complexity, is there a way to go think about that? So there actually is. This third algorithm is based on an algorithm developed by somebody called Floyd. Okay, and the algorithm is called Floyd's cycle detection algorithm. So to explain this, I would like to take the example of Captain America and Sam Wilson running around a track in Captain America and the Winter Soldier. I don't know if you guys, if everybody has seen that. I'll put a link in the description down below. So what happens is, in the Winter Soldier, when Captain America and Sam Wilson are running in a track, Captain America is so fast that he crosses Sam very often and keeps saying to your left, to your left, to your left. So what happens is this was um, so there was a track like this. Sam and Captain America started at the same point. When Sam was here, Captain America took a cycle and Captain America was here and he said to your left. When Sam reached here, he took another cycle and Captain America reached here and said to your left. So basically, um, Captain America was faster, right? And since this thing was a cycle, Captain America fell behind Sam and came to the same point and then crossed him again and then came to the same point as Sam, right? So this basically gives me the idea that when I have two pointers that are running in different speed in a cycle, they would meet at one point. If the track had been a straight line and Sam and Captain America had started at the same point, Captain America would reach the end, Sam would be somewhere here, and they would never meet. So when there is a cycle, they would meet at some point, and when they do meet, we know that there is a cycle in it, right? So to do the same thing over at a linked list, what I can think of is, let's say we have a list of this sort. Let's use some colors for this. Okay. Uh, so we have two pointers. Let's say C, S. So when let's say Captain America jumps twice the speed of Sam. So when Sam reaches here, C reaches here, right? Next, Sam goes here, and C would reach here. When Sam reaches here, C would reach here, right? The next step Sam takes here. In this point, C would reach here, right? Sam reaches here, C reaches here. When Sam reaches here, at this time, C reaches here, and this is the point where the both pointers meet. And once they meet at a point, we can return true, saying there is a cycle in the list, right? And if they never meet, and if we see that the C has reached to a point where it is facing a null or where the next is a null, we can say that the list ends at that point and there is no cycle in it. This process can only tell you whether there is a cycle in the list, right? There's more to this algorithm which can be used to find the starting of the cycle, where in this case, this is the point where the cycle starts, right? So Floyd algorithm has more to it, which can be used to determine the starting of the cycle in a list. But we don't need that as part of this question, so we are going to stop on this. Let's go over to Leetcode to see how we can write the code for this problem. Yeah, to solve the problem, we are going to use Java, right? So as we discussed, we need two nodes. List node, let's say cap, which points to head in the beginning, and list node Sam points to head in the beginning, right? And we need to go through the loop, and if we end the loop, we return false, right? So what's the loop condition is basically if cap while cap is not equals null and cap dot next is not equal null. So we are going to iterate until this point, and if we encounter cap equals null or cap dot next equals null, we come out of the loop and we return false, right? While in the loop, if we see what cap needs to do is cap jumps twice, cap dot dot next, and Sam jumps once. Sam equals Sam dot next. And at every point, we check whether cap and Sam meets each other. And if they do, we know that we have a cycle in it. We return true here. And if we never encounter this and we come to the end of the loop, we return false, since that's the case where there is no cycle and we have found a null, right? So let's go ahead and submit the solution here. Cool. So that's about it. We have a solution with 100% faster than 1% of Java solutions online. Thanks.